Hello and welcome to my presentation on topic modeling on user stories using word movers distance. My name is Julian Gülle and I study computer science in my second semester at the Technical University of Berlin. Berlin, as you can see, is quite a busy city, and this is a bit similar to the internet. This busyness of the internet is actually the reason why new data sources emerge, which can also be used for requirements engineering. For instance, we've got App Store reviews or tweets where some of our stakeholders, especially our users, share their opinion on our products. This is actually the reason why CrowdRE becomes more popular. But one problem persists. So how can we derive useful insights from large amounts of data, especially when it's produced by the crowd? To find an answer to this question, we looked at the CrowdRE dataset, a dataset which was created in 2016 by Muru Kanaya using Amazon's Mechanical Turks. The crowd workers produced a set of 3,000 smart home requirements, which were created using a form like this. If you are familiar with agile methodologies, you see that the crowd workers were forced to follow the user story pattern. So they were asked to, for each new smart home requirement, they were asked to provide a role, a feature that role requires, and a benefit which would arise from that feature. Also, they were asked to select one of the 5 application categories, which we also call domains, which is energy, entertainment, health, safety, or other, if none of the 4 other domains apply. The resulting requirements look something like this. As a home occupant, I want music to be played when I get home so that it will help me relax, associated to the health category. Or another example, as a homeowner, I want music to play whenever I'm in the kitchen so that I can be entertained while cooking or cleaning, associated to the energy category. What we did now was we wanted to apply topic modeling on this dataset so that these sentences, which I just mentioned, are at the end plotted into 2D space, and similar sentences should be plotted next to each other, while different or requirements like this one about a serial eater who wants a robot that pulls him his Captain Crunch is further away from the other requirements. To get user stories to these vector representations, we did the following. We found 3 approaches. In general, each of the approach needs to process the user stories through an NLP pipeline first, and then we could apply the techniques, the topic model techniques, and finally use TSNE to reduce the dimensions and plot the user stories in a coordinate system. Our first approach uses latent directly allocation. We use bag of words to first construct a word vector for each requirement, and then we use TF-IDF to weight these requirements. Finally, as mentioned, we use LDA to identify the topics. Our second approach is a combination of word-to-vec and principal component analysis. Here we use word-to-vec to build matrices of word vectors for each requirement. So for each sentence, we replace the words as a smart homeowner and so forth with a corresponding word vector, and we concatenate these word vectors so we end up with a matrix which has this the width of the sentence length. We do this twice, once with self-trained word vectors which are trained on our vocabulary, and once with Google News word vectors which were trained on the Google News dataset. Due to the differences in the sentence length, we have to use PCA on each of the resulting matrices to align the sentence, the width of the matrix, so that every matrix has the same dimension before we can use the TSNE. Finally, our third approach uses word2vec and word movers distance. It is very similar to our second approach. There is one big difference though, because after training the word2vec model, we can calculate a matrix of distances. That matrix looks like this, and each of the requirements here, as you can see, for each requirement, we store the word mover's distance, so the distance from that sentence to all the other sentences in the matrix. This matrix can then directly be used with TSNE to then plot the distances of our sentences. Let's have a look at our results. Each of our approaches associates a requirement sentence with a word vector. To somehow verify our findings, we then also use the application domains and relate these to the plotted sentences. As you can see, from the distribution, we expect a large cluster of safety requirements to appear and two almost equal clusters of energy and health domains. And with the other category, we expect this to appear as noise in the data. Our first approach, the latent directly allocation, results in many clusters, which unfortunately are still unrelated to the domains. This gets a bit better with our second approach, the word embeddings and the PCA, where with the self-trained word vectors we've got at least two domain clusters, but the domains are still mixed. With the pre-trained word vectors, we can also start to recognize some domain clusters. As you can see here in the lower left of the right cluster, the entertainment, this is predominantly entertainment requirements, and the top part of it consists of energy requirements. Also, the sentences with similar vocabulary here are relatively close. This means two sentences talking about room thermostats and keeping the temperature constant will be plotted next to each other if they have a high overlap in vocabulary, whereas sentences with similar meanings, like the two which I showed you earlier, are unfortunately still far away from each other. With our third approach and the self-trained word vectors, this problem is somehow solved because the sentence similarity becomes spatially visible. Also, some domain clusters become apparent. We've got an energy cluster down here, we've got an entertainment cluster in the center of the plot, and a cluster predominantly consisting of safety requirements at the top right up here. Finally, with the pre-trained word vectors, the clusters now are clearly demarcated. Also, even though if it looks like this approach is a bit worse than the previous one with the self-trained word vectors, the two new content classes become apparent. So on the left here, this cluster contains requirements which are mostly related to parenting and children, and that top cluster here is mostly concerned about pets. What have we learned? Well, as mentioned, we worked on a dataset with user stories. This limited the text length and forced a structure to the text. We assume that this actually was beneficial to our analysis. We cannot say, though, because of this, how these approaches perform on completely unconstrained natural language. Also, the dataset is relatively small when it comes to automatic topic modeling. Relatively small because if we compare our dataset to the Google News dataset, which is 2000 times the size of our dataset, we can easily see that we've got a relatively small dataset when it comes to the field of machine learning. Finally, because of the short text, we've got some other limitations. we've missed some word co-occurrence information, and also the document similarity is hard to measure with back of words. As mentioned, all of our approaches associate a user story with high-dimensional vectors. To plot these sentences, we had to apply dimensionality reduction techniques. As these techniques only provide an approximation to the original data, information may be lost in the process. Also, the labels we used to compare our findings were set by the crowd workers, and they have not been validated any further. So our previous example, as a homeowner, I want music to play whenever I am in the kitchen so that I can be entertained while cooking or cleaning, was set to be energy by the crowd worker, but we found it to appear in an entertainment cluster, which seems equally valid to us. Finally, another outcome of the data being collected by the crowd is varying quality in the data itself. So this requirement, as a food cook, I want diet system that control kitchen auto suggest to eat time suggest follow it, so that health diet make a special time to eat, which is, by the way, associated with the energy category, is just one example to show that, of course, the varying quality in data could affect the quality of our results. Still, what we found is that CrowdRE allows for a high reach of stakeholders. The feedback is unstructured though, also in the sense that it can relate to basically anything of your application area, especially if it is something which is as generic as smart home. We found that automatic techniques are definitely necessary to make sense of the data, but a combination of word embeddings and word movers distance was most successful to deal with this challenge. We found a reasonable number of clusters, we have a good overlap to original domains, and we found new insights into the data. So, with that being said, thank you for your attention.